Today let's go over solving first order differential equations by using the integrating factor method, or in simple notation IF. So this is where you have a differential equation with dy over dx plus vy equals q, and this must be the form in order to solve using this method here. The p and q these are not constants but rather functions in terms of x. So p will be a function in terms of x such that it's p of x. I've simplified it here in the equation, in the general expression here, and then q will also be a function of it. So in this method, what we generally do here is we set an integrating factor with if, and then we equal that to e to the power the integral of p with respect to dx. So we integrate the function of p which is with respect to x and then we integrate that entire thing with respect to x, and this will be the integrating factor. And in this case we just simply move this p into this expression here, and then we continue the integration. And you should also understand that when we are solving an a differential equation of this type, the solution will be of the form e to the power integral of p dx multiplied by the function q, and then we integrate that with respect to dx. So it is just a simple matter of substitution into this expression here, and then eventually solving it out. And now you always got to remember that you have to put the plus c because we are finding a general solution, unless they of course give us the boundary conditions. In a case like that, we'll have to substitute the values of x and y and eventually find the value for the constant c to find a particular solution. In this case, we'll look at a simple example where we find a general solution for the differential equation. So let's look at an example. Let's consider the differential equations, the first order differential equation. Therefore, from this expression here, we can clearly see that the function p of x is equals to -4. The function q of x is equals to e to the power x. As I previously mentioned, the simple notation for a general solution of this type will be given by e to the power. So the first thing that you can do when you get a question like this is to simply mention the integrating factor. That way you'll score the first 2 marks in the question. In this case, the integrating factor is going to be e to the power of p, in this case which is -4 dx. We then substitute this into this general notation here. Then it will be e to the power -4x y is equals to integral of e to the power -4x multiplied by q, which is basically e to the power x dx, and do not forget the plus c of course. And then we will have e to the power -4x y. Therefore, by a simple integration, we can eventually come into a general solution where we will have e to the power -1 over 4x y, and this will equals to -1 over 3rd e to the power -3x plus c. And this will be the solution for the first differential equation, the general solution.